Hi, everyone. It's already 10 o'clock here. Welcome to this Ferncast webinar hosted in collaboration with Thimeo Audio Technology. This is part one of a webinar series titled Level Up Your FM Distribution. I am Virginie from Ferncast Marketing, and I'm delighted to have you join us today. In this session, we will explore extreme new support for microMPX, FM over IP, and its seamless integration with Thimeo stereo tool. You will discover the latest innovation in FM distribution and learn how microMPX can enhance your audio workflow. This webinar today will last 1 hour, and there will be at the end a live Q&A session, but please feel free to drop your question in the chat at any time. You will also have a chance to win a Ferncast t-shirt with our traditional quiz, so stay tuned for a chance to win. And last information, I will be sending out the on-demand recording to all of you by the end of the week. Well, let me introduce the speakers of the day. Tobias Dornbusch, product expert at Ferncast. Detlef Wiese, CEO of Ferncast. And our guest speaker today, Hans van Zutphen, CEO of Thimeo Audio Technology. Thanks, Hans, for being with us today. Let's have a look at the agenda now. Detlef Wiese will first kick things off with an extreme overview, giving you insight into the platform's capabilities. Then we will dive into microMPX via stereo tool. And finally, Tobias Dornbusch will demonstrate microMPX transmission via aixtream. I'm pleased now to give the floor to Detlef Wiese, who will provide you with an overview of aixtream.
Thanks, Virginie, for this nice introduction. Well, I would like really to go back to, let's say, roughly a bit more than 5 years when we started with Ferncast and the idea of doing a pure software product for audio real-time applications with the requirement to be very robust in the 24/7 environments in lots of areas in broadcasting, radio, and also high security applications. And for that purpose, we all set together the team, which is still in the same way existing as we started. We set together and created aixtream with all its possibilities and features. At the time when we started, end of 18, beginning of 2019, we did not really actually know what all will come and what exciting journey we would make with our customers, and got so many requests, so that aixtream has been on a continuously growing path in terms of features, modules. It's a real toolkit. It's like the Swiss Army knife of audio processing, and has become also more present and has reached quite representative footprint. So what we say is we optimize and revolutionize your audio logistics. So audio logistics means getting audio, putting it from one location to the other, processing it, doing the best to the audio so that actually it arrives at the destination in a way you really would like to receive it for your particular application. So when we look a bit more to aixtream, how it runs, I mean, aixtream, you see on the next slide, can run as appliance. It supports ARM, Intel, Raspberry Pi. It can be in a Docker container, in a virtual machine. We always focus on aixtream as software, and sometimes, of course, package it. What you can see on this slide is a packaging for a ResPad. It's a general hardware which is available, where we put aixtream for reporters, or we put it on servers for certain applications. And the range of applications has become really broad. So we started with streaming, but have extended to lots of other areas. And it's important for us that you, our partners, our customers, come to us with your particular block diagram, with your challenge, with your workflow. We say, hey, I want to go to the next step. I want to get to the next level, and then after some while of a very fruitful and beneficial cooperation, we will end up with another Ferncast extreme use case in your place. I'm sure that during this session today with Hans in particular as our guest speaker, and also Tobias giving you a bit more an in-depth view to extreme, I think lots of areas will be considered. But just very roughly, on this 24/7 radio software extreme, it's extremely scalable. And yeah, when we say 1 to 1,000 channels, I mean, actually, of course, it could also be 1,001 channel. So it's extremely scalable, extremely efficient, can be very small and lean, which means also extremely reasonable in price, but can also really cover very, very heavy applications, with lots of features and lots of processing. And also your audio I/O, of course, can be used very flexible. There's of course a huge trend to do everything on IP, but still, of course, also other audio I/Os are supported. Yeah, if we look to the range of applications, and that actually was not the slide we would have shown when we started. So when we started was streaming, it was a bit of communication, but all the others have come in addition. So while starting with streaming originally in Germany with Deutschlandradio and the first streaming platform, more and more applications have come to us, and we are a very customer-driven company. So whenever someone comes, when we say, okay, yeah, it fits to the extreme software development, and it's something which we can also offer to others, it's interesting for us to make the software growing. And yeah, I won't go through everything here, but you can see that areas like maybe DVB Max or DAB D Max is in this. Its loudness has become very much in the foreground very recently, but we cover also really studio transmitter links and lots of areas. Also offline services like podcast file creation with a quite big emphasis and focus on the loudness processing. So yeah, we are very proud to say that we are number one for radio streaming in Germany for the public broadcasters. So that's, I think, something we have reached during the last years. But beyond this, of course, we see lots of international customers using our software already, and it's on a growing path and an increasing footprint.
Thanks, Detlef, for this overall presentation. It's time now for our quiz. So let's have a look at the question. So the question today: what was the second first name of the person credited with inventing stereo? So please use the chat to everyone to write your answers. The first one with the right answer will win a Ferncast t-shirt. Good luck. So Hans is now going to present Stereo Tool and the benefits of microMPX. Hans, the floor is yours.
Yeah, and I have to say, I don't know who that person would be actually that you just asked this question about. I should know that, I have a feeling, but I don't. So I'm going
and
to.
it's a second first name. Huh?
I know, but I don't even know the first name, so I don't need know the last name either. I have no idea. So let me share my screen as well. Yeah, so hi, I am Hans van Zutphen. I'm the owner of Thimeo Audio Technology. We make audio processing software and since recently also hardware for, well, mainly radio stations. I'll just start at the end because I can start with software, but many people are more familiar with hardware. So we have a hardware processor, which you can see here, but we started out with software, and this here is what our software looks like. It's called Stereo Tool, as you can see, and this is just a full FM processor, and I will quickly go through the features of it, and then after that, I will go through the specifics for microMPX and why we need microMPX. As a company, we try to make at least one thing every year that no one has done before worldwide, just to keep things interesting. And because of that, we have a lot of unique features in our software. And one of the things is that we don't just process, we also first repair the audio. So we have a lot of features like the perfect declipper, which you might be familiar with, which takes clipped audio and can basically completely fix it. We also have a delossifier that can do something similar for MP3 files. It's not as spectacular, but at least it makes them a lot more acceptable to listen to. We have a dehummer. So let's say you have a remote broadcast somewhere and you have a 50 or 60 hertz hum from a bad cable somewhere and you can't figure out where it is quickly. Then we have a way to filter it out. Of course, you should eventually fix it, but for the time being, you can at least get rid of it. The quantizer is a bit less interesting, so I'll skip that one. We have a noise gate, so if you have older music, we can get rid of the noise. Azimuth correction. If you have older music, often there is a phase issue between left and right because things have been mastered via tape. And that if a tape head is misaligned, you get all kinds of really annoying effects, and we can fix those. And even if a single instrument has phasing issues, we can fix that. And that's a big help for FM, for example, because if reception goes back to mono and you have one instrument that's out of phase, then that one instrument would disappear and make the stereo and mono switching way more obvious. And by fixing the phases, we basically get rid of that issue. Then the processing itself. A very big upgrade that we have done this year is traditionally you would have an AGC, a multiband, another multiband, maybe another compressor after that, all together to create your dynamic audio, to control the dynamics of your audio. And all those stages typically fight each other. So the AGC goes down. If it goes down too fast and the multiband goes up more slowly, then you get a gap in your audio. If the multiband goes up too fast, anyway, all those things will cause issues. So we have created a very, very powerful new compressor design, which can replace all of this in one stage. And the huge benefit of this, well, it has multiple benefits. One benefit is this thing can run at infinite ratio mode, which means that it's extremely consistent what comes out. So typically you would use the AGC at infinite ratio and then later stages at lower ratios. And the effect of that is that, for example, if you have a song that doesn't have much highs, you will pull up the highs somewhat, but not fully. And this new thing allows you to do it completely. And the other big benefit is it's way simpler to set up because you basically have two sliders that control your whole audio. You can still fully control what it sounds like, so it's not, but it's all dynamically adjusting to the input. So instead of configuring what it should do, you're now configuring what you want the end to sound like, the end result to sound like. We can generate bass subharmonics for recordings where those have been filtered out, which is typically older music because everything that was mastered for vinyl, they basically had to filter out the deep bass sounds because the needle would skip. We can also generate upper harmonics. So if you have small speakers, you don't hear any of that deep bass, but you can hear the upper harmonics, and that at least gives you the impression that there's bass. And again, for older music, we can increase the amount of highs and generate fake highs at higher frequencies. We have lots of ways to widen the stereo. We can introduce all kinds of phase effects, which you can use to, for example, get a more boomy bass. And clipping, which I will get into much deeper in a next step of the presentation. Something that we just added last month or 2 months ago by now is if you listen to AM stations, typically you miss all the S sounds because, well, everything above 4500 hertz is filtered out. And that means that often if you hear an AM station, and I know there are not that many AM stations left, but in some places there are, all the highs are missing, and it's even hard to understand what people are saying because all the S sounds are missing. All the F sounds are missing. That's what it would sound like. So we created something that replicates the highs at lower frequencies that can actually be transmitted over AM, and the end result is that it sounds far less dull and yeah, actually much more. I mean, it's still cut off at 4500 hertz, but it sounds way more tolerable. Yeah, we try to do things that nobody has done before. So we've had RDS in our software since 2008. And as far as I know, we were the first with that. Due to something that went wrong due to long story, it doesn't matter. We had to add, there was something that happened that forced us to basically create a full RDS encoder. The one from 2008 was very limited, but yeah, we at some point had to add everything that's supported basically. So any RDS encoder you have, we can probably match the features in our software directly. So then you don't need an external RDS encoder anymore, which is really useful if you want to do everything in software. We even just this year added RDS2 support. And with RDS2, you can now transmit logos, and we don't support it yet, but also slideshows. Basically, all the things that DAB has that FM doesn't have on RDS, we can now transmit. So here's an example. In this case, we have, if you look at the bottom, you see a station logo field. We've just entered a PNG file there. And this here is an RDS decoder, and you can see that, an RDS decoder, and you can see that the logo appears here. So we can actually transmit your station logo on FM. This adds 3 extra carriers, which you can see in the image here. So you see the left plus right audio, the pilot, the left minus right, which is this whole area here. Then the traditional RDS and 3 extra RDS carriers for the RDS2. An interesting effect of RDS2 is that it can affect the RF bandwidth because it has a lot of high frequency content. And actually, that's the thing anyway, but I'll get back to that in the next presentation. Everything can be remotely controlled. So if you have a playout system and you wanted to talk to our software, you can do that with things like this. We support RT Plus as well. RT Plus is what tells your receiver what the title and song name, for example, are. So it can also look up album art automatically that way. And I will skip this. We also have a version with which you can run multiple instances on one PC, but that's not really relevant for this current presentation. So I will go to the clipping part, which is where it gets interesting. So typically, stations want to be loud. And I know that if you're in Germany, you have BS412, and it's not really a thing anymore. But there are still some benefits of the things that we're doing here. They're just not as big as in other markets. But let me just go through the loud stuff, and then I'll go back to BS412 at the end. So typically, stations want to be loud, and that's achieved mostly by clipping. But clipping has a lot of drawbacks. It creates distortion, it reduces your dynamics, and especially with pre-emphasis, it reduces the highs quite a bit. So you get a bit of a dull sound, which is very flat and not very dynamic. So we want to achieve loudness, but we don't want to clip. So there are a few ways of doing this. The simplest thing that everyone can do for free is you can tilt the RDS by 90 degrees. The pilot and RDS waveforms are basically added up. If you tilt your RDS by 90 degrees, it's still being decoded, but the end result is about 1% lower. So you get 1% of extra headroom for audio, which is about 1/10 of a dB. It's not much, but it's free, so that one is easy to do. But we can do a lot more. Traditionally, what happens is that the left and right audio is clipped. Then you do the stereo encoding and add the RDS to it. So what you basically get is, in this image, the gray area is basically the left plus right clipped audio. And that has a very specific, threshold where the clipping stops. Now we need to add the pilot and RDS. So to do that, well, you can see the pilot and RDS drawn in green at the top and at the bottom. We need to shrink the left plus right and left minus right, so the left and right audio, to make room for the pilot and RDS. But you can already see, for example, I hope you can see my mouse. If you look at this part here of the green bit, if there had been some audio peak that goes up here, we could have fit that in here without any issues. So we clipped it, but we didn't really need to. So we're basically throwing away loudness, which we could have used. So let me go through how this works, and I hope that things will become clearer from this example. So let's say we have left and right audio, and this here is the left and the right channel, and we have a waveform, and as you can see, the left channel is much louder than the right channel, and the blue line is the clipping level. So traditionally what we would do is we would clip it like this. And you can immediately see the effects. We throw away a lot of loudness and dynamics. And also, both channels look very similar now, so we are also losing stereo separation by doing this. And that makes sense. If one channel is louder than the other and we clip both, then they will get closer together. So this is something we want to avoid. So what we can do is we can look at the left plus right and the left minus right. So imagine adding these two waveforms up, then you get what you see here on the left. And then imagine subtracting the two, so you take the one on the left minus the one on the right, and then you get the image that you see here on the right. Just the difference between the two, that one blob. So if we look at what happens during modulation, well, what happens is the left minus right part of the signal is modulated at 38 kilohertz, which basically means we multiply it with a sine wave of 38 kilohertz. Now there's a 50% chance that this thing will flip in direction, as you can see in the image below. I mean, if we multiply this blob by that sine wave, basically the blob flips around and points to the bottom. So if we add up that flipped version of that blob with the left plus right signal, then the resulting signal looks like what you have at the bottom here. And you can see that far less audio is exceeding the blue line. So if we clip now, we are throwing away far less. And if you demodulate the audio in this case, it actually looks like this, which, as you can see, is much closer to the original. And I think, yeah, here we have the two different versions. So by using this trick, we get the image below instead of the image on top. And the benefits are clear. It's much louder, and we're talking about 2 or 3 dBs. It's clearly much more dynamic. Well, it sounds less clipped because, well, it is less clipped, so it's almost not clipped. There's obviously much better stereo separation, and this affects the highs most because you need small spikes that can fit into the stuff that can flip around. So we get much more highs, and we've measured it, and we can typically get about 5 dB more highs through if we want to, which is a lot. And this is not all yet, but it's almost all. There are 2 more things that are important. The first one is So your reception is affected strongly by how wide your RF bandwidth is. The wider it is, the more reception issues you get. BS412 is actually a way to lower your RF bandwidth, but we don't need BS412 to do this because at this point in our clipper, we know everything. We know the pilot, we know the RDS, we know all the phases of everything. And we can combine all that information to, in the software, basically do what an FM transmitter does. So we have a software-based exciter and spectrum analyzer in the software, which both feed back to the clipper. And by doing that, we can perfectly control the RF bandwidth. And there is a mask that the ITU recommends you should stay inside of. Almost no processor does that because, well, nobody else basically has this algorithm. But we can control this and keep the RF bandwidth inside this mask without sacrificing any unnecessary stereo separation. Typically, you do this by reducing stereo separation or reducing modulation levels. And we don't need to because we can basically just stay within this line and just keep everything there. Which means that you're not transmitting, because typically a receiver will use a bandpass filter to cut off these sites, because this is typically also where the next station would be transmitting. So this will be thrown away by the receiver anyway, and throwing that away will also introduce some sort of distortion. So by doing this, we reduce distortion in the receiver and we reduce interference with neighboring stations. And also multipath distortion, because a wider bandwidth causes more multipath. So lots of benefits. There's one more, and that's a really interesting one. The left plus right section, the left minus right section, so the one here in the middle of your MPX, it's typically symmetrical, but it doesn't need to be. We can just boost one side and reduce the other. We can actually just transmit one side and remove the other one completely. And well, by analyzing the lower and upper sideband separately, you can see that the waveform that comes out, if you look at the waveform, has peaks at different locations, which are of different heights. So this here is the same signal with lower and upper sideband modulation, which both will decode properly in your receiver. So both will sound exactly the same, but you can see that the peaks are at different locations. So by constantly switching and taking the one that has the lowest peak level, we can actually gain another dB of loudness without clipping. And the result of that looks a bit like this. It's typically a bit asymmetrical, so the right part of the left minus right will typically be a bit lower, which is actually has the unplanned but nice benefit that it actually reduces the RF bandwidth further, because higher frequencies cause bigger RF bandwidth. So another thing that will also improve your reception. This has some impact on the waveform. So if we look at demodulated audio in practice, then this is what it looks like. This is your normal left-right demodulated audio. Now, just composite clipping with the tricks I mentioned will give you a lot more dynamic audio, as you can see, and a lot louder audio. So these are the extra dBs that I mentioned. And this single sideband, dual sideband switching will make it even louder and even bigger. Here are some other songs with the same similar effect. And yeah, you can imagine, if you just look at the waveforms, how much better this sounds. I don't have any samples to play at this point here in the demo, but yeah, this is a massive effect on your station sound. Final thing to mention is the cleanness of the MPX signal. By having a very, very clean pilot, many receivers use that to see how good your reception is and decide based on that if they can play the audio in stereo or should fade back to mono. And we've had multiple reports from multiple stations that switched from other processors to ours, that suddenly their stereo reception range was like 50 kilometers further away from the transmitter site than before. which is, I didn't believe it at first, but I've heard it so often now that, yeah, it has to be true. So that's composite clipping, which takes me to the final part of the presentation, microMPX. So we have hardware products now, but we used to do only software. And well, people were afraid of running software at the transmitter side. So we had this really nice processor, which gives you this massive gain in loudness and everything. But people were afraid to run it at the transmitter side, and they would run it at the studio and then go to the transmitter with traditional mechanisms, typically left-right audio. Well, okay, but that means that you lose all these benefits because, well, we need to have the full signal with pilot and RDS in the clipper to be able to do all these tricks. So we needed to solve this, and we needed to make a codec for this. So we had a few design goals. Well, we wanted to have all the benefits of composite clipping. So basically, it needs to be as if your processor is at the transmitter side. So we want the extra loudness. We want the stocker mask ITU 1268 is that mask that I showed before. So that's the reception mask basically. So we want that. We obviously need perfect peak control because otherwise, well, you get overshoots on your FM signal, so that would be bad. We want a very clean signal, so the pilot and RDS cannot be damaged in any way because that would obviously also affect things. And we want no perceivable audio quality loss. So yeah, as I said, basically it should be identical to putting your processor at the transmitter side. And the last one, lightweight, so it would be easy to integrate because, as I said, we were not a hardware company, so we needed others to do that. Yeah, low bitrate would be nice, but that's the last requirement and not the first. So how does it work? Well, you have your FM processor, and it might directly encode microMPX, and then you can directly go to the network, or if it doesn't, you can use a standalone microMPX encoder. That goes to the network, potentially with backup links and stuff like that. And on the decoder end, well, on the transmitter end, you have your FM transmitter, which might take microMPX directly, or if it doesn't, you can have a decoder hardware box there. And that's basically the idea. So let me just show you what the software looks like to get a bit more hands-on. So in this case, we have the software version, and it's in this case, you basically just select the sound card that gives you the signal, and you have to set the input gain to 0 dB. By the way, that's very important, and that's the one thing you need to know when you set this up. Always the modulation level has to be 0 dB, and the reason for that is if we are close to the peaks, to the 0 dB clipping level, we need to encode things more accurately because we cannot have any changes there because then we would get overshoots. So we need to know where 0 dB is. And the solution for that is to just always feed the signal at 0 dB. The version that's built into processors, so the one in Stereo Tool, the one in our hardware box, the one in the Omnia 9, the one in the latest Orban processors, they all do that automatically, so you don't have to worry about it. But if you use a standalone microMPX encoder, you would. Then on the encoder side, you can fill in a number of IP addresses and port numbers, and at this point we have room for up to 100. If you need more, let us know, we can add more. We have support for multicast as well, or broadcast, so you can use that as well if you want, if you need more, but we can have up to 100 of these. And then on the decoder side, well, all we need to know is the port number. And here we can also have backups, and they can also have different priorities. This is an older screenshot. Just last week we added different priority levels, so you can actually have different streams coming in, and this thing will switch between them based on priorities. Now, the design itself, it's designed for FM. So what do you know about FM? Well, it will never remove sound, it will only add noise. And our codec, to be as nicely matched with RDS as it can, should do the same thing, because that means that those two will mask each other and you will never hear it. So if we have to, and we don't usually have to, but for certain sounds we do, then we only add shaped white noise, which means we don't add pre-ringing, we don't add watery highs. You don't get spectral gaps that are fatiguing to listen to, and very important, we do not affect audio watermarks in any way. So you can safely transmit audio watermarks and for audience measurement without any issues. Because we don't use traditional codecs, we don't have, because codecs like MP3 or AAC, they will always move sounds around, and moving sounds around will also cause Stochamask overshoots. Because, well, everything that we tweaked perfectly to match will move around in time, and that will cause issues. So that's also a thing that this codec doesn't do. We don't have degradation in RDS signal, and we've measured that we have more than 90 dB stereo separation. This requires, obviously, that we either have the signal coming in from a processor directly or digitally. If you have an analog signal, 90 dB stereo separation with MPX is just not really feasible, but with digital, we can get over 90 dB stereo separation. Now, at high bit rates, and this image here shows a bit of microMPX, a bit of MPX audio. So you can see the same things here from bottom to top. So if you know how to read these graphs, this is a graph that shows spectrum over time. So you can see the left plus right audio, the pilot, the left minus right symmetrical, and on top the RDS. If we encode this at 800 kilobit and then decode it again and subtract the two from each other, the end result is basically almost perfectly identical. And if you measure it, we're typically at about minus 100 dB of difference. So no way you will ever notice this on FM. So it's not a lossless codec for all intents and purposes, at least at this bit rate it is. At lower bit rates, there are more effects, and I'll just skip through this because it's just a lot of stuff. But anyway, what the important part is, we did a lot of listening tests, and for version 1, which is years ago, and the latest version is much better, but for version 1, we did listening tests at the Max Planck Institute with dozens of people for multiple days. And the end result was that at 320 kilobit, people cannot hear any difference. So that's how we decided on making 320 kilobits the minimum bit rate. So great, that's 320. But what if you want to go over satellite and your bandwidth is expensive? Or what if you want to use 3 or 4G, 4 or 5G, sorry. Then 320 kilobit might still be a bit much. So we wanted something for that situation, and we have, and that's microMPX Plus. And here we basically ignored some of the design goals, or we scratched them. One is the Stochamask compliance. And the reason for that is, well, I mean, nobody else, no other processor even has it. So yeah, we can probably get away with not fully complying to it. And the other one is, well, we allow, at least at the lowest bit rates, some amount of quality loss. It's going to be hard to hear, but it might be, it also depends a lot on your processing settings themselves. So it's a hybrid solution which combines microMPX with how traditional codecs work. With that, we can go down to 176 kilobit. At 176, the sound might get slightly metallic, especially if you have left minus right asymmetry, the one that I mentioned with the switching between the left and right, the upper and lower sideband switching in the clipper. If you have stuff like that, that all needs to be encoded, of course, and that makes things harder. So once you get stuff like that, there might be some metallic effect, but only at the lowest bit rates. Typically, we gain about 70 kilobit by using this trick. So 256 is comparable to 320 at normal microMPX. although we still cannot guarantee stochastic because we might somewhat have some movements over time. So where can you find microMPX? Well, you can find it in a number of FM processors, our processors, Stereo Tool, which is now integrated in Ferncast software, so you can use it directly from there. You can get it in a number of hardware processors and also software processors. So we have it in our box, in the Omnia 9, in the Optimod 5750 and 5950. Then we have all these hardware boxes that support it. So we have boxes from 2W.com, Omnia, Digigram, Gates Air, Tieline, Exeltech, Syntec, Phantomtronics, and there are actually more coming, but yeah, can't mention them yet. What many people do, and you see the image on the right, is just run a Raspberry Pi at the transmitter side. Just in the Netherlands alone, there are more than 150 transmitters on the air with a Raspberry Pi, and those things are surprisingly reliable. So might be a cheap option to use this. There are also a number of FM transmitters that have it built in. So Aqua Broadcast has it, WaveArt has it, and Bext has it, although I'm not sure if they're completely ready yet, but these three have it, and there are also more coming. Yeah, so this is an overview of all the hardware that currently supports it. Important thing to know is probably to know something about is probably error recovery. So you're sending your signal over, well, possibly just public internet, and yeah, packets might get lost. So we have forward error correction to fix that. You can send identical streams via different links. And that means that, well, if the same packet comes in through different links, then it will just ignore any copy. So it will ignore every second packet. So you can just unplug any of the cables. As long as one of the two cables is plugged in, you will have your signal. And then I already mentioned redundancy and priorities. You can have multiple streams from different encoders. And for example, public broadcasters might want to do this. They might want to have a bunch of encoders here, a bunch of encoders there in a different building. They can both send to the same location. If you don't care about priority, it will just switch over whenever one of the two drops out. You can also set a priority for one of the two, and yeah, just make it switch over to the other one only if the first one disappears. We're working on RIST support. RIST is a standard from video broadcast, basically. And this has all these features and a re-request mechanism. And that re-request mechanism is really interesting because initial tests that we've done show that even with 80% packet loss, we can typically still have a running stream. So that might be useful to know. microMPX supports GPS signal frequency networks. So if you want to run multiple transmitters and synchronize them with less than 1 microsecond shift between them, we can do that. Even on a Raspberry Pi if you want to with cheap hardware. So yeah, so that's an option. And microMPX Plus also supports RDS2. So if you want to use that, we have it as well. Because we have all these different vendors, sometimes there are things where different vendors want to talk to each other, and we can standardize things between vendors that can be added to the stream and will also be transmitted. And GPIO is one of those. So
yeah, thanks, Hans. We have one question in the chat. Is asking, what does SSB do to stereo separation?
Single sideband. Well, that's a good question. So a few years ago, there was this whole hype around single sideband, and the idea was that single sideband would make your reception better. The problem is that many receivers that are on the market now are actually using the composite signal, how do we call this? The quadrature signal, it's called. So if you take your pilot and flip it by 90 degrees and then decode your stereo, you basically get this asymmetry signal. And that is normally silence. If there is a lot of stuff there, then there are receivers that are on the market now that will detect that and think, okay, reception is bad, we need to blend to mono. So there are some receivers that don't like it at all, which is also why you can use it, but only up to like 10% asymmetry. And the images didn't look very asymmetrical, and that's because of that, because you can go higher. The gain in loudness is very small and it can potentially cause issues. So with 10%, we know that we can be safe and it has no effect on stereo separation. But if you go higher, it might. So I would very much recommend that people do not enable single sideband mode completely in their processors, because many processors have added it because it was a bit of a hype a few years ago, as I said, but it doesn't really seem to work. And some receivers really hate it.
Yeah, there's another question. Could any of the features you mentioned give a better, louder for 0 dB MPX power BS 412?
Yeah.
Also, what did you mean by BS 412 being not relevant in Germany anymore?
Oh, no, sorry. I meant that the loudness gains are not relevant in Germany, because no, there is no way to gain loudness this way. It does make the sound a bit better, because even with BS412, there's still some clipping happening, not much. And what you can hear is just nice hi-hat spikes that they sound a bit more open and a bit brighter. But that effect is small. The one thing you can do if you want to have more loudness is have more stereo separation, because the left minus right, because it's multiplied with the 38 kilohertz, is actually 3 dBs lower than the left plus right in your calculation of the power of your signal. So having more stereo separation will give you some very, very small amount of extra loudness. So the question is, what about latency in the transmission path? We have optimized the code currently for performance and not so much for latency. And because of that, it requires at least about 200 milliseconds. We could go lower. We've run tests where it went down to 20. But yeah, we have never really released that, because also many of the hardware units that support microMPX wouldn't be able to run it. If you run it on Raspberry Pi, it would be feasible, but yeah, it's not really. The thing is that most stations have so much latency in all their paths anyway that it's not really relevant. And I mean, even 20 milliseconds is too much to listen to yourself on headphones. So yeah, we didn't really optimize for it. We can if we have to. So typically, if you have all the forward error correction and stuff like that enabled, then you would typically get around 1 second.
One more question. Hans,
Yeah.
thanks for the great presentation today. Any thoughts on audios 2 support in EU? It seems that not a lot of receivers are supported. Even self-driving cars do not have this feature.
True. So it needs to start somewhere. And yeah, so far, we're the first processing manufacturer who has integrated it. So hopefully, if stations start to transmit it, which you can do without any costs really, because of the Stocker mask filter, so it doesn't really affect anything. Hopefully that will push some car manufacturers to enable it or something, but I don't know, it's hard to say. It really depends on what car manufacturers do. The signal exists, the standard exists since last year, so it was actually standardized last year. So until last year, nobody could even implement it because there was no standard yet. So it's a good question. There are definitely a lot of markets where it would be more interesting, and maybe those would be the ones where more could happen. For example, to mention the US. In the US, DAB is not a thing. And many stations are using HD only because that allows them to transmit stuff like this. And HD is very, very expensive. because you need to buy extra transmitters and you have all kinds of licensing fees. So those stations might be the ones that might want to push for this, but the question is if manufacturers of car radios will listen to that.
Right. We have a very last question here. Might as well pick this up one too. Yeah, once again, great presentation. Would you prefer a 50 kilohertz signal at plus 3 dB MPX power versus 75 kilohertz 0 dB? So BS 412.
Just to clarify, do you mean 50 and then still get 3 dB of MPX power, or do you mean 50 and then such that once you measure it, it's 0 dB, so you're actually processing for 50 with plus 3, but transmitting it, and then if the latter, then I definitely prefer the 0 dB 75 because, well, lowering your clipping level will just make the sound worse. So, good.
Okay.
Well, apparently there used to be processors on the market that had a hard time controlling the level with BS412, and they actually tricked it by lowering the clipping level. And while that works, the problem is, even if you lower the clipping level to 50 kilohertz, I wasn't going to say it to mention any brands, but yeah, so even if you lower the clipping level to 50 kilohertz, that actually has a pretty small impact on the loudness because, well, the loudness is made by those spikes. The thing you clip off is the spikes, and that doesn't really carry much of the loudness, so it really doesn't do much. Yeah, I tried it when I made our BS412 limiter. And I have to say, and I can imagine that many people did it this way because, well, that BS412 limiter was really difficult to design. We ended up having 20 different predictors for what's coming in the next minute, which all work together to control the level. So you can imagine that was, well, I expected to work on it for 2 days and it took me 6 weeks. So, but yeah, so if you have limited processing power, you cannot even do it that way. Yeah, exactly, and that's a bad idea. That actually explains why many stations in Germany don't sound as good as they should. I actually noticed last time I went to Switzerland last month for a presentation at the RDS forum because of the RDS2 stuff. And while I was driving to Germany, we have a station nearby here that's running our latest clipper version and our latest compressor version that I mentioned. And until now, every time when I went from the Netherlands to Germany, and in the Netherlands, most stations are at like +6 or +7 or even +8 dB of MPX power. All the time when I went to Germany, the first thing I would say was, okay, I have to turn the level up a lot, but it sounds a lot better. And this was the first time where I thought, every single station I heard sounded worse than the station here that was running at +7. So yeah, that was surprising.
Thanks, Hans. We still have a few minutes left, and we would like now to give you a live demo on a microMPX transmission via aixtream. So we will leave now the floor to Tobias, who will give you then a short live demo. And if you would like to stay at the end of the webinar, if Hans can stay also, we can continue with some live Q&A question. Yeah.
Thank you, Virginie. So I will quickly share my screen here. Quick note, because we're already far into it time-wise. I will keep this relatively short, but I very much invite you to check out our YouTube channel and, of course, our website, because there's some prior webinars that we have made where you get a bit more information and also similar demonstrations to the one that I'm about to give, but with a bit more time spent on it. So just very quickly, as Detlef mentioned earlier, of course, aixtream is a very broadly capable, let's say, audio encoding and processing software, and which of course raises the question of how exactly do we realize this in the UI, in the graphical user interface? How do we enable the viewer to set up these very complex audio workflows, which of course can also include both a stereo tool for processing or for the microMPX encoding and transmission and so on. So what we came up with back in the day is the so-called pipe concept. And that is what you see some examples of here with these colorful circles right now. Let's zoom a little bit in here. So effectively, the concept is quite simply that the entire audio workflow, everything that happens with the audio signal in the system is represented by these what we call pipe elements. That's the circles that you can see here. So if we take a quick look at the top one as an example, we have a regular audio source. So this could be like an audio interface, USB or PCI Express, something like that, that is connected to the system, that is accepting the channels coming in. Volume control is enabled, the level is being measured. In this case, it's MP3 encoded and then goes out as an aixtream stream in this example. So could be for like web radio and so on. But in exactly the same way, you can set up just about any kind of audio workflow. So this is actually the menu you would see when you're setting up a new pipe. So as you can see, there's a whole pool, as we call them, of sources, audio processing options, encoding, and of course, these things are then the destinations or outputs, as the case may be. So to give a simple example how this could look, let's say instead of a regular audio interface, you have an AES67 signal coming in. So that would be audio over IP in our system. So that's what you choose. Of course, you also want to have a volume control and level measurement. Let's say this is also maybe a web radio. So you want metadata insertion. And let's say you want it AAC encoded. And in this case, let's say it's a HLS stream, in which case you also would need the HLS upload element as well. And yes, so this would be the initial setup for your connection. But as I mentioned, by the same token, you could set up just about any kind of connection. As you can see here, there's a very large range of different inputs and outputs we support. Even things like demuxing existing, for example, DAB signals or FM from the air, if you have, of course, appropriate receiver hardware connected. Even like straight IP data we can accept for very specific use cases, WebRTC and so on. And then on the destination and output side, of course, we mirror most of these, but also some extras or very specific ones, like the MPEG TS muxing with DVB compliant and so on, Right. And then once you have done the initial setup, you can do the actual detailed configuration by simply clicking on the elements, and then you have also the respective options for that. So for instance, we're looking at the AAC encoder right now. Of course, the settings for what kind of AAC you want to encode, and choices like bit rates and so on. And in fact, in most cases, there are additional expert level options also available. Again, those of course depend on the pipe or the pipe element in question. Now, bringing this around to stereo tool, as I mentioned, there's effectively two ways how to use stereo tool in our system. You can have it simply in the, let's say, in the middle as a regular audio processing element. If you want to simply use the audio processing features, for some of which that Hans already mentioned, or for the microMPX. So quite simply, we're going to set up a very simple pipe here. A test signal is coming in and going to stereo tool. Then we find this pipe that I just set up. We're going to start it. And here's the interesting bit. Once you have enabled stereo tool in our system, you can actually use your existing license keys that you may have already bought in the past from Thimeo to use the stereo tool in our system. So you don't need to buy a new set of keys in that case. You would simply add them here. But if you just want to test around, you can do this even without the keys. Then it would simply mean that stereo tool is in demo mode. So once you have set up the pipe like this, there's actually a special icon here, which in fact opens the actual stereo tool UI, screenshots of which we've actually seen earlier. on the Xstream system. So it's exactly the same UI that you may already be familiar with from Stereo Tool. And you can do all the audio processing or microMPX setup here exactly as you are used to. Right. So that was the quick run of this. And I think I will give back to Virginie for the quiz resolution.
Yeah, thanks, Tobias, for this well, quick presentation. Of course, if you have any questions or requests, please feel free to contact Tobias, our product expert. He can also answer your questions or give you also a personalized demo. And yeah, this webinar is coming to an end, but yeah, it's time now to reveal the quiz answers. So we had a few answers in the chat, I saw, and we got a winner, Detlef, I think, because the right answers was Dower. Would you like to comment, maybe, Detlef?
Yeah, I think it's I think a bit complicated if you look in depth to the stereo inventions, and I think also Carl Georg Eilers was a good mention, of course, who did lots of work for stereo sound on TV. Alan Dower Blumlein is very well known, and well, he had a pretty short time on this planet, but within that time he did lots of inventions, and in the I think the beginning of the 30s he worked well, fantastic on stereo. So Dower is fine because he has also a second name. There was actually another guy in the 19th century, and that was Clément Ader, and he did the theatrophone in France, and this was actually, I mean, the very first stereo transmission from a theater, from an opera. He just had a carbon microphones, and he put two wires, and people had, you know, very big headphones. So, but he had no second name. So, and Alan Dower is very well known, very well known for stereo. So Dower is fine. So we have definitely a winner. Did you see, Virginie, who was the first with Dower?
Yeah, I think the first one was Richard.
Hey, Richard, congratulations.
Yeah, so we are now coming to the end
cool. Richard, perfect.
of the webinar. So thank you for joining us today. We hope you enjoy the session. Thank you, Hans, also for your great presentations. We would like also to invite you to the part 2 of this webinar series, which will take place in February. Hans will be again our guest speaker, and we will then explore advanced audio processing with the Stereo Tool. So stay tuned for details. Thanks again for joining us, and have a nice day.
Thanks.
Thank you.